This video, we are gonna discuss the question 5 in Theory CBT. In the question is given the joint probability of x and data accordingly, and we are required to find the variance of data if given x, where the conditional variance of data given x, variance of data, and the conditional expected value of x given data. The solution is as shown on the screen. For variance data, for the conditional variance of data if given x is relatively easy because we only need to find the expected value of data square if given x and the expected value of data if given x. And after that, we could just take the expected value of data square if given x minus by the square of the expected value of data if given x. For the expected value of data if given x, we are required to find the expected of x, the joint expected value of x and data, and we need to divide the value by probability of x accordingly because that's how conditional variance works. For expected value of data square if given x is kind of similar because we just need, the only difference is we take the joint expected value of data square instead of data, and x equals to x. And for this expected value, we are required to divide it by probability of x accordingly as well. For the joint expected value of x equals to x and data, we just need to sum the joint probability of x and data times with data accordingly. And for data square is kind of similar. It's just that we need to replace the data with data square. For variance of data, we will be using the conditional variance, the conditional variance formula, which is from the double expectation. Variance data will be equals to the expected value of variance of expected value of variance of data if given x plus the variance of expected value of data if given x. And for the expected value of x if given data is actually same as it will be having the same procedure as the expected value of x if you expected value of data if given x. It's just that we need to change the position of data and x, and now we need to find the expected value of x, the joint expected value of x and data equals to data, and we need to divide that probability by that expected value by probability of data. And the detailed working is shown in the Excel sheet. This is also shown on the screen. For this table is finding the single probability of x and data instead of the joint probability. So what we need to do is only to sum all of the probability of the data value together. Is like if data is equal to 3, then we sum all of the value together. The joint probability of x equals to x and data equals to 3 together, and we will be able to obtain the value of probability of data equals to data, respectively. So after having the probability of data and the probability of x equals to x, now we will be able to proceed to the next step, which is finding the expected value of the joint expected value of x and data. And in this table, we are finding the expected value of x if given data. It's actually quite easy and simple to do because for the expected value of x and data equals to data, we just need to multiply the x with the respective probability, respective joint probability, and we just need to sum all of this combination together, and we will be able to get the joint expected value of x and data equals to data accordingly. By having this joint expected value, we will be able to find the expected value of x if given data. So to find this conditional expected value, we just need to times the expected value with the probability. We just need to use this joint expected value and divide it by the probability of data if equal to data because it is conditional on data. So we will be able to get the conditional expected value. In this following table, we're actually doing the same process, but now we are finding the joint expected value on difference x instead of data. So it's the same procedure which we would take all of the probability of x equals to 4, the joint probability of x equals to 4 and data equals to data, and we will times it, we would multiply it with different value of data, which is 3, 4, 5, and 7. And after that, we would be able to get the joint expected value of x equals to x and data. And for the data square, joint expected value of x equals to x and data square is just the same process. And we would just square the data value and multiply it with the joint probability of x equals to x. Like for example, in this row, we are trying to find the expected value of x equals to 4 and data square. So we just take the probability of x equals to 4, the joint probability of x equals to 4 and data equals to different data, and we will times it with the data square accordingly, and we will be able to get the expected value of x equals to x and data square. By having these two values, we are able to find the probability of, we are able to find the expected value of data if given x. So we just need to take the joint probability of x equals to x and data, divide it by the probability of x equals to x accordingly. Like for example, this row is still about the x equals to 4, so we just take the probability of x equals to 4, and we will be able to get the expected value of data if given x. And for data square, joint expected value of data square if given x is just the similar process, just that we now take the data square instead of data, and we will be able to get the value. By having these two values, we will be able to find the variance of data if given x, because the formula for variance would equals to expected value of x squared minus the expected value, and minus the square of expected value. So it's just the same for in here, and we take expected value of data square conditional on x minus the square of expected value of data conditional of x, and we will be able to get the variance of data if conditional on x. Finally, we are going to find the finally, we will be finding the variance of data. It's relatively easy with all those information we have found above. So For the expected value of variance of data if conditional on X, we just need to times the variance of data if given X with the probability of X equals to X, and we will be able to get the expected value. Actually, it's the same formula as the normal expected value, just that it is just on variance, so it's just the same formula. And after that, we will be required to find variance of expected of data if conditional on X, and it's not that hard to find this value as well, because we could be finding the expected value of data if conditional on X by using the double expectation formula. So at the end, so next we will be finding the expected value of data conditional on X. So for this expected value is relatively easy to find because we could directly use the double expectation formula, which is E data equals to E expected value of E data conditional on X. And to find this E data is actually very simple. It's very basic formula because we could just take the probability of data multiplied by the data value accordingly. Then we will be able to find the expected value. After that, to get this square value, we just need to use the expected value of data conditional on X times with the probability of X equals to X, and actually we need to square the value of expected value of data conditional on X. We need to square this value because we are finding the expected value of data conditional on X squared. So actually we just need to view the expected value of this conditional variance inside the bracket. We just need to view conditional expected value. We just need to view it as an variable. So we could just do it as usual. So we just square the expected value of data conditional on X and multiply it with the probability of X. And we will be able to find this expected value as well. And after all, we would be getting the variance of expected value of data if given X by subtracting the square of expected value of data if given X from the expected value of E data X squared. After all, we will be able to get the variance of data easily by adding these two values, which is the expected value and the variance value in both, and we will be able to solve this easily.